Okay. Okay. Hello, everybody. Thank you so much for having us here at OCMC. We're presenting today about an instructional resource for teachers called Project Math Talk. And this features a different kind of instructional math video, maybe different than the kind of videos you've seen on YouTube, like Khan Academy math videos. We thought, me and my co-presenter, Mike Foster, thought we could present this crash course in the style of frequently asked questions. So we'll go into our background and introductions, sort of the design of our videos, and lastly, how you can access and hopefully use the videos in your classroom through our website, www.mathtalk.org. So feel free to browse the website as we talk, pose any questions you have in the chat, and we'll also have some time for discussion. So we'd love to have everybody's participation. So first of all, who are we? I'm here with my co-presenter, Mike Foster, and my name is Isabel White. We are both current doctoral students in the Math and Science Education PhD program at San Diego State University. And we work under our advisor, Joanne Lobato, who is a faculty member at San Diego State. And in addition to being math teachers, we also identify as math education researchers. So our Project Math Talk is an NSF-funded project that involves the development of math videos. And these videos feature student dialogue, so hence the math talk, for teachers to use. And our role is sort of to develop the videos and research how other students can learn mathematics from these videos. So we thought you all might be wondering how Math Talk videos are different than other videos. So to give you a flavor for the videos, I'll show you a 1-minute clip from our Parabolas unit. And this unit features 2 high school students, Sasha and Keone. And we refer to the students as the talent. So let's see if this will share sound. Please let me know if you all can.
Can you find a point without plugging into that equation? Just by using what you know already about.
And sorry, I forgot to mention, we're gonna watch this clip, and I do want you to think about what you notice about the clip and how it's different than other videos you've seen. I encourage you to put things in the chat as you watch the video. It's only a minute long. So go ahead and put things in the chat and we can talk about the features of this clip. Okay.
About the geometry of parabolas?
Right there.
Why?
Because it's equal distance from our focus and our directrix.
Where's the focus?
Yikes. Well,
we can plug in the origin because that's what we used our equation for. Like our equation only works when it's on the origin.
Okay. Can you use another colored pen and get the focus and the directrix in there?
All you, buddy.
okay, so what's our focus? You want our focus to be 1, right?
Sure.
Yeah, okay. So our focus.
Why is it 1?
Why is it 1?
I don't know.
Well, what was your thinking?
Because that's like a general place to put it. Well, that's what I thought.
Okay. Did anyone notice anything? Go ahead and put your ideas and thoughts in the chat, or you can unmute yourself and say what you noticed. Okay, I see. It shows both the students and their work. So yeah, the way that the video is sort of presented, you can see their work on the left and the students' faces as well. The facilitator was asking them questions. Yes. The teacher didn't answer a single question. She wanted the students to learn through discovery by themselves. So student directed. Students are being encouraged to explain their understanding. Students were engaged. These are awesome observations. The questions weren't just why. More so, these questions were building on top of the student's knowledge. Great observation. Anyone else have anything to share about the videos? So yeah, I noticed you all picked up on sort of visually how you can see both of the students' faces. The students are being featured, building on the students' knowledge. This is getting at sort of the main features of our video, which is that they feature pairs of students who engage in dialogues where they convey authentic confusion and they persist to resolve their mathematical struggles. So hopefully you were able to see a glimpse of that in this video. Next, I sort of wanted to pose the question, why might students benefit from engaging with these types of videos? So our website, mathtalk.org, lists some aspects that we think are beneficial for student learning, but there's also some emerging research that supports these features as well. So first, students who watch the videos are watching other students, which we call the talent, talking about mathematics. So there are several studies that have compared the effectiveness of videos that feature students talking to videos with only one voice. So something like a Khan Academy style video where there's only one person talking. And they actually found that dialogic videos, so videos with students talking, lead to increased learning outcomes as opposed to monologic videos. So this is one feature of our videos in that they feature students talking to each other. Students who are watching these videos could also benefit by seeing the talent confused about the same things that they are confused about. So you saw in that other video with Sasha and Keone, they were a little confused about what the focus meant, where the focus was supposed to be, and that's a technical term related to parabolas, but the idea is that they're authentically confused, and you get to see that on the video. And this is informed by research that suggests that videos that feature multiple conceptions and confusion can lead to increased learning. And in a more recent study with our videos in particular, Lobato and Walker found that learners watching our videos engaged with the talent, so Sashi and Keone, as if they were in the same collaborative group. So they experienced things like, relating to the talent's mathematical personalities. They were predicting what they were going to do, comparing their own strategies with the talent, and acting as if the talent could hear them. So this is something that Lobato and Walker called quasi-collaboration. So the students felt like they were in a group with the students in the video. And so these studies suggest that this feature can lead to increased learning as well. So another feature of our videos, another benefit is that the talent in the video are working on conceptually rich tasks that ask the students to go beyond math procedures to understand why things work and where they come from. I think someone in the chat picked up on this in the video clip, that students are constantly being asked why, what do things mean? And this is, not by accident. The design of the videos are specifically in alignment with the Common Core standards and practices. And by design, they include cognitively demanding tasks with deep level questions. And research has shown that videos that feature students thinking deeply and working on challenging tasks benefit students learning from the videos. And lastly, students are able to make connections across videos. So our videos are short in length. They're about 6 to 7 minutes each. If you're looking at our website and you click on one of the episodes, you'll notice they're no more than 10 minutes at the longest. And they're each part of a larger lesson, which is part of a larger unit. And they're meant to tell a mathematical story and really to encourage this connection making from the students watching the videos. And one of the ways we achieve this is by having several episode types. So we have making sense, repeating your reasoning, exploring, and reflecting. And our making sense videos involves having students think about, or the talent rather, thinking about the problem context. The exploring videos usually involve these conceptual challenges and the resolution. Repeating your reasoning involves the talent practicing their reasoning. And in these videos, the viewers are directed to stop the video and work on a task and then compare their own work to that of the talent. So kind of break the fourth wall there. And then lastly, reflecting involves the talent explaining or justifying their previous reasoning behind their method. So as a result, the talent grow over the course of 40 videos to reach a level of sophistication in their mathematical reasoning, so that the students who are learning from the videos can hopefully reach that same level of sophistication in their own math reasoning. So on the right here, you'll see each of the talents in our 3 units that we currently have developed on our website. So we have parabolas, we have proportional reasoning, and algebraic expressions currently, each featuring different pairs of students. So I'll turn it over to Mike Foster, who is going to talk about some of the resources for teachers that there are on the Math Talk website.
Awesome. Yeah, thank you. Before I go into too many more details, I guess I was going to go a little off the cuff here. We talked a little bit about like why research suggests like our videos might be useful and like the direction that the researcher pointed us, or the research pointed us when making the videos. I was wondering what you guys thought of the videos. Is there anything that stands out that you think is like beneficial to whether you're learning? I notice some of you guys are students, or to your classrooms. Is there anything specific that maybe like other styles of videos that you've used in the past don't have that you like about our videos? Are there just any general reflections, if you guys either want to unmute or put in the chat about like these style of videos? And if not, no worries. Okay. I think the point that we're really trying to make, oh yeah, that is actually a phenomenal point. Somebody in the chat says they normalize making mistakes. So we talked about how like the research suggests these videos should contain misconceptions. And we kind of think like if our videos have that, it can kind of allow viewers to empathize. Like math is hard, and if they see somebody else struggling, they can empathize with that experience, and maybe that leads to these like quasi-collaborative experiences. The videos capture the real reactions of students, even though they're confused. Yeah, absolutely. Again, like math is hard. It's normal to be confused. The thinking aloud, that's exactly right. Sometimes it's hard to get students to think. So maybe like seeing these videos, or rather it's hard to get students to think out loud. So seeing students thinking out loud can maybe like show productive models of behavior. Also, they show how students work through a problem. Yeah, and like moreover, there's like math content within these videos, and it shows like a process of productive struggle, like slowly working towards like what we deem as like a correct answer. Cool. So it sounds like a lot of these features stand out to you guys and you see them as potentially productive. That's awesome. So next, as Isabel said, we're going to talk about some of the features. Some resources for teachers that are on our website. And again, I think this is our third plug, and a QR code. So you guys are all obligated to click on the link and or scan the QR code if you want to take a look at our website. Go to the next slide. Thank you, in the chat as well now. So on our website, if you guys navigate there, Isabel also mentioned this, we currently have 3 units completely filmed and on the website. That is a proportional reasoning unit, a parabola unit, and an algebraic expressions unit. Most of this content kind of surrounds like algebra content and our quote unquote talent, the students in the videos. They're typically about high school age, wrestling with this material. This project has taken place over 2 NSF funded grants, and we are currently in the process of filming or plan to film 5 units. So we have in the can, as they say, an exponential functions unit as well as a logarithmic unit. Those should be on the website in the coming months, but as of now, we just have the 3 units in blue. Additionally, on the website, if you navigate to one of the episodes, you can roughly see in the bottom left-hand corner what the episode screen looks like. The site has both a student and a teacher portal. So students can go and find the videos, or teachers can go and find some additional resources. For the students and the teachers, if you see in the bottom left-hand corner, that's super small, there's a little math task button. And what's contained in that math task button is a worksheet that shows what we call a paired task, which we kind of define roughly as a task that's similar to the task contained in the video. And the idea is while students are watching the video, it's best that they're also engaged with some type of, end goal. So we have paired tasks that accompany all of our videos. And then specifically in the teacher portal, we also have something called episode supports. So some episode supports include student conceptual challenges, focus questions, supporting dialogue, and math extensions. Just to illustrate what one of those are on our next slide, this is an example of possible focus questions. And within this, we provide like a possible point where you could pause the video and ask a discussion starting question for your students. So for this instance, in the parabola unit, we suggest pausing at 201, and we ask our students carefully, analyze the definition of a parabola. What parts of the definition did Keone and Sasha use when they drew these 3 points? What parts are not represented in their diagram? The goal of these focus questions and the others listed on the previous slide is to provide scaffolding. So you have the opportunity to just not, throw a video on screen and hope that the students are attending to it. It's so you can kind of connect to the students, get them working on the task, and hopefully even starting fruitful discussions. There's a lot of incomplete thoughts that are presented within the videos. And we kind of think that that's a great opportunity to see if your students are recognizing like, oh, this person has a conjecture, but maybe they can recognize where it's falling short of a completed solution.
Michael,
Yes.
we have a question. Should we move your videos into Edpuzzle to pause and ask the focus questions?
I do not know what Edpuzzle is.
Okay, Edpuzzle is where you take mainly YouTube videos and you put pauses in them and post like a multiple choice something. They answer and then they move on.
Okay.
And I would, that's all.
Yeah, that's an awesome suggestion. It's a good place to get the timestamps within the videos and getting students to like interact in that way. We're not exactly sure, I guess I would answer your question by saying, of a use model for within classrooms, but I do think that like has viability. One thing that we particularly look forward to is kind of using the videos as a more broad discussion starter. So not as evaluative of like, oh, like, do you think like this answer is this? And more like, why do you think that answer is this? In an idealized scenario, obviously. And this nicely transitions into the next slide, in fact. Thank you for the question, Dennis. How can I use Math Talk videos in my classroom? And as I said, we don't really know. This is an open question. That's us with a little like thinking expression on. We were hoping maybe you guys had some ideas about your own classrooms. Generally, we think videos could possibly be assigned as homework, sending your students to a specific video unit that we have and having them work on paired tasks. Alternatively, as I mentioned, it could be in class to start a discussion, maybe with ed puzzles where they, like a specific timestamp is marked. I guess this could also be useful for homework. You could have these timestamps marked with ed puzzles for your students to work on. And then would you want to use them as a whole unit? We kind of have like roughly 40 videos comprising a unit, so you could use it to kind of replace part of your lessons. We don't have exactly a use model for within classrooms, so if anybody has any thoughts on how you could implement these types of videos in your courses. Alternatively, do you guys implement any type of videos in your classrooms? And what does that look like? Is it as homework? Is it as, in lieu of instructions?
Yeah.
We've conducted a couple studies with our videos showing to pairs of students. One of the findings we presented, Lobato and Walker, about the quasi-collaboration, but we've yet to get into classrooms. So we don't, as I said, have much experience with that. So Debbie says she likes the idea of it being used to start discussions. And again, this is kind of this idea of integrating misconceptions, like seeing if students had similar misconceptions is certainly not the right word, but incomplete solutions, using that to like stem class-wide discussions like, oh, were you thinking about that problem in the same way? Dennis says, it's fun and better. Yeah, absolutely. There's, kid-like language. They kind of have fun and laugh around with each other, which is always good to see in our classes. Julia, I would have these videos as a pre-lesson or even after lesson for classwork or homework. Yeah, definitely. And again, like there's content being covered, so it can function in that way as well. Cool. I think we have one more slide. Oh, yeah, I think I already briefly touched on this, but will there be more videos coming on other math topics? We have 5 more planned lessons that we hope to get to. So multiple binomials, trigonometry, linear equations, and then the 2 exponential and logarithms should be on the website in the coming months. And hopefully we plan to expand beyond this. These videos take a while to produce because there is a lot there's a lot of planning and lesson structuring going on behind the scenes. But we would like to have a whole, Khan Academy library one day. But our videos are not as quick to produce. And if you guys have any ideas of what you think a video unit, a productive video unit to include would be, we are all ears. Things that kind of maybe in your class that segued into great discussions that maybe students struggled with but had nice insights on. We love to hear that kind of stuff. Debbie asks, would you ever do some elementary? We've definitely talked about it. There's an image of one of our video units, the proportional reasoning. It's with students Kate and Christopher, who were in the 7th grade, I believe. And unfortunately, at that age, it was really difficult with behavioral issues to get them to, we're filming, we only have you for this amount of time. We need you to get through the material. It was grade 6 students. Thank you, Joanne. And it was more difficult, but it's a proof of concept. It's definitely an option. I think the younger you go, you certainly introduce these other variables that make it difficult. For my dissertation right now, I created a series of videos at the undergraduate level. And again, as a proof of concept, it also extended really well to that. Students still kind of emotionally attached to the people within the videos, which is cool to see. So there seems to be a lot of opportunity to expand beyond high school level content. Cool. Well, I think that is all that we have. I thank you guys so much for having us. And thank you for your